In today's lesson, we'll be looking at how to simplify logarithmic expressions. And if you have not subscribed to this channel, kindly subscribe so that when new video is being uploaded, you'll be the first person to be notified. Now let's get started. So we start with this set of examples, and we have here as example 1, and it says that simplify logarithm of 9 base 4 plus logarithm of 21 base 4 minus logarithm of 7 base 4. Now to solve this, we are going to apply the laws of logarithms. And if you have not watched our video on the laws of logarithm, kindly click on the link above to watch it. Now we can see that they have the same basis, so applying the laws of logarithm becomes so easy. So now we have our question as logarithm of 9 base 4 plus logarithm of 21 base 4 minus the logarithm of 7 base 4. Now we can see that we have three terms here. So solving these three terms, we can take them one after the other. So considering the first two, that is logarithm of 9 plus logarithm of 21 base 4, they are adding and they have the same base, which means we can write it as a single logarithm as, so logarithm to the base 4. And then once the logarithms are adding and they have the same base, we can multiply the argument. So that is 9 times 21. And then we have our minus logarithm of 7 base 4. Now we know 9 times 21 gives us 189, which means we have logarithm of 189 to the base 4 minus the logarithm of 7 to the base 4. At this point, we can see that there are two logarithms of the same basis subtracting. And from the laws of logarithms, if we have something like this, we can rewrite this as a single logarithm as logarithm of 4. And then once the logarithms are subtracting, we can divide the argument. So that is 189 divided by 7. Now we ask ourselves, what is 189 divided by 7? That gives an answer of 27. So to the base 4. Now with this, we know 27 can be expressed as powers of 3, which means 3 exponent 3 gives us 27. Now we continue, and our solution now becomes logarithm of 3 exponent 3 to the base 4. Now from the laws of logarithm again, we said that if you have something like this, then the power of 3 can be written as a coefficient to the logarithm. That is the power index law, which means we can send this 3 here to be written as a coefficient. That is 3 logarithm. So let's write it well. So that is 3 log of 3 to the base 4. So we just sent this exponent to this side to become the coefficient. That is from the power index law of logarithm. And this is how we can simplify our question. So this is the final answer. Now let's move to the next question. That is example 2. In example 2, we have logarithm of 3 to the base 2 minus logarithm of 15 base 2 plus logarithm of 50 base 2. Like we can see, they all have the same basis. So applying the laws of logarithm goes smoothly. Now with this, let's write our question as logarithm of 3 to the base 2 minus logarithm of 15 to the base 2 plus the logarithm of 50 to the base 2. Now, writing this as a single logarithm, considering the first two terms, we can see that they have the same basis and they are being subtracted, which means we can write it as a single logarithm by dividing the argument. That is logarithm of 2 to the base 2. We have 3 divided by 15. And then we have logarithm of 50 base 2. Now, 3 divided by 15 gives us 1 out of 5. So we have logarithm of 2, that's to the base 2, 1 out of 5, plus the logarithm of 50 base 2. Now at this point, we can see that they all have the same basis, that is log 2, and then they are being added. So once they have been added, we can also write it as a single logarithm by multiplying the argument. So we have logarithm to the base 2, that is 1 out of 5 multiplied by 50. Now we can further simplify this, and we have logarithm to the base 2, and 5 cancels itself 1 and goes into 50 10 times. So at the end we have the logarithm of 10. That is it. Now it means it's the same thing as the logarithm of 2 to the base 2, 10. And we can further reduce logarithm of 10 to the base 2, which means that we are going to express 10 as products of two numbers. Now we can see that logarithm to the base 2, now 10 can be written as 5 times 2. That is the product of two numbers. Now by applying the same laws of logarithm, once we see something like this being multiplied, we can expand by using the laws of logarithm. That is logarithm of 2, that is to the base 2, 5, plus logarithm of 2 to the base 2. So this is a single logarithm, and when we expand, this is what we get. Now we can see that we have the logarithm of 5 to the base 2 maintained, and then plus logarithm of a number to the same base gives us 1. So at the end we can rewrite this as 1 plus logarithm of 5 to the base 2, and this becomes our solution. That's why we are simplifying logarithmic expressions. We are going to reduce it to the lowest term, and that is the meaning. Now, having known this, let's try the next set of examples. In example 3, it says that evaluate 2 log 5 base 10 minus half log 16 base 10 plus 4 log 2 base 10. So we can see that they all have the same basis. So applying the laws of logarithm is so easy. So you're applying the laws and the properties of logarithms. Now we have our question as 2 log 5 base 10 minus half log 16 base 10 plus 4 log 2 base 10. And with this, we can see that this 2, the coefficient of the logarithm 5 base 10, that is the 2, can be written as an exponent to the argument 5 by applying the product index law. So at this point, we can have logarithm of the argument 5 exponent 2 base 10 minus, so the same half can also be written as an exponent to the argument 16 by applying the product index law. That is logarithm of 16 exponent half base 10 plus the same thing applies to 4 log 2 base 10. That is the logarithm of 2 exponent 4 to the base 10. Now at this point, we can break it down, and we know logarithm of 5 exponent 2 base 10 can be written as logarithm of 25 base 10 minus, now 16 exponent half simply means that is 16, that is the square root of 16. Now when we take the square root of 16, we know we're going to get 4. So that's the meaning of 16 exponent half. So you have logarithm of 4 base 10 plus logarithm of, now 2 exponent 4 gives us 16. We have our base 10 here. Now we can write this as a single logarithm by considering the terms here. Now with the first two, they all have the same basis, so writing it as a single logarithm, then since they are subtracting, we can divide the argument. So that is 25 divided by 4 plus the logarithm of 16 base 10. Now before we simplify 25 out of 4, now let's consider the logarithm of 10, 25 out of 4 plus logarithm of 16 to the base 10. Now with this, we can write this as a single logarithm to the base 10. We have 25 divided by 4, and once they have the same base and then they are adding, we can multiply the argument. We continue, and we can see that we have logarithm of, now 4 cancels itself 1 and goes into 16 4 times, and we know 25 times 4 gives us 100. So logarithm of 100 to the base 10. Now, further reducing logarithm of 100 to the base 10, we know 100 can be expressed as 10 exponent 2. That is 10 times 10. It simply means that 10 exponent 2 gives us 100. And then we have our base 10 here. Now, if that continues, we can see that we can rewrite this as 2 logarithm of 10 to the base 10 using the product index law, which means this 2 is going to serve as a coefficient to the new logarithm. So we have 2 logarithm of 10 to the base 10. Now, from the properties of logarithm, we said that logarithm of a number to the same base is 1, which means you have 2 multiplied by 1. That is log 10 base 10 gives us 1. At this point, 2 times 1 is the same thing as 2. And this becomes our final answer. Now, let's try the next example. That is example 4. It says that simplify 3 log x base 10 minus half log y base 10 plus 1. You can pause the video and try this. Now, like we just read the question, 3 log x base 10 minus half log y base 10 plus 1. Now let's see how the question is written. It's not written as y plus 1, but the plus 1 is it's another term on its own. So let's know that. Now, by applying the product index law, we can rewrite 3 log x base 10 as logarithm x exponent 3 base 10 minus the same thing implies to half log y base 10. That is the logarithm of y exponent half to the base 10 plus, now 1 can be written as logarithm of 10 to the base 10. Now, why are we writing it as logarithm of 10 to the base 10? We can see that they all have, we can see base 10 here, base 10, and we can also write the 1 for it to have the same base as 10. Knowing what that, we can also write the argument as 10, because we said a logarithm of a number to the same base gives us 1. So in this case, if this base happened to be 2, and this side 2 happened to be 2, then we'd have written our logarithm of 10 base 10 as logarithm of 2 base 2, because logarithm of a number to the same base gives us 1. But because they all have the same base as 10, then we decided to write it as 10 and then choose an argument of 10, so that we can imply that property of logarithms, that a logarithm of a number to the same base gives us 1. If that is clear, then we continue with our solution. Now, at this point, we can see that we can write this as a single logarithm by considering the first 2 terms. Now, we can see that the logarithms are being subtracted. So, writing it as a single logarithm, then we're going to divide the argument. So, we have s cubed divided by y exponent half plus logarithm of 10 to the base 10. Now, we can further simplify a solution, and we have logarithm of, so we have logarithm to the base 10, and at this side we have s cubed, and we know that y exponent half means square root of y, so we have y square root plus the logarithm of 10 to the base 10. Now, further reducing this, they all have the same basis, and then they are being added, which means you can write it as a single logarithm by multiplying the argument. That is the logarithm of s cubed divided by square root of y multiplied by 10. They all have the same base as 10. Now, at this point, reducing it, we have logarithm. So by multiplying, they are going to have logarithm to the base 10, and 10 times s cubed give us 10 exponent s cubed divided by the square root of y. And this is our simplified solution to our question. Now let's continue the next set of examples. Now example 5 says that without using tables or calculators, evaluate logarithm of 75 out of 10 base 10 minus 2 logarithm of 5 out of 9 base 10 plus logarithm of 100 out of 243 base 10. Now they all have the same base, and applying the laws of logarithm, like we said earlier, is so easy and simple. And at this point, if you have not subscribed to BakoMaths, kindly click on the subscription button so that we get along as we try to find the solution to this problem. Now we have logarithm of 75 out of 10 to the base 10 minus 2 logarithm of 5 out of 9 to the base 10 plus we have here as logarithm of 100 out of 243 to the base 10. Now with this, we can apply the laws of logarithm like we said earlier. Now we can see here as 2 logarithm of 5 out of 9, and these two can be written as an exponent to 5 out of 9. So maintaining logarithm of 75 out of 10 base 10, and then writing this as logarithm of 5 out of 9 exponent 2 base 10 plus we maintaining 100 out of 243 base 10. Now with this, we can further simplify our solution by maintaining logarithm of 75 out of 10 base 10 minus logarithm of, now this implies that the square is going to affect 5 and 9. So which means 5 squared gives us 25, and then 9 squared gives us 81 plus logarithm of 100 out of 243. We have base 10 here. We also have base 10 here. Now we have been able to simplify it, so we can write these as a single logarithm by first, since they all have the same base, we have logarithm to the base 10. Now the first two terms, they are subtracting, so writing as a single logarithm, then we are going to divide. That is 75 out of 10 divided by 25 out of 81, and then we have that of logarithm of 100 out of 243 to the base 10. Now if that continues, then we can reciprocate that of 25 out of 81 so that we get multiplication here, and then we simplify our solution. Logarithm of now 75 out of 10 maintained, reciprocating this, we have 81 out of 25. Don't forget the base 10 plus logarithm of 100 out of 243 base 10. Now if that continues, then we can see that 25 goes into itself 1 and goes into 75 3 times. So we can see that 3 multiplies 81, that's going to give us 243, and 10 multiplies 1 gives us 10. So we have logarithm of 243 divided by 10. Our base 10 2 is there, plus logarithm of 100 out of 243 base 10. Now we can see we have new set of logarithms, and they have the same basis, and at the same time they are adding, so you can write it as a single logarithm. That is logarithm of 243 out of 10 multiplied by 100 out of 243 to the base 10. Now Having known this, then we can see that our logarithm to the base 10 can be simplified as, now 243 cancels 243 and 10 cancels itself 1 and goes into 100 10 times. So at the end we have logarithm of 10 here. Now logarithm of a number to the same base gives us 1. That is, logarithm of 10 to the base 10 is 1. So our solution to this question is 1. Now let's try the next example. Example 6 says that evaluate without using tables or calculator half log 25 out of 4 base 10 minus 2 log 4 out of 5 base 10 plus 320 out of 125 base 10. So this is similar like the previous example, that's example 5. So you can pause the video and try your hands on example 6, and afterwards you can follow our solution. Now we have half log 25 out of 4 minus 2 log 4 out of 5, not forgetting the base 10, and we have logarithm of 320 out of 125 base 10. Now with this, we can see that there is 2 log 4 out of 5 base 10, and we can rewrite this as it being an exponent to 4 out of 5 by applying the power index law. So focusing on that, then we have half logarithm of 25 out of 4. We have our base 10 here minus logarithm of 4 out of 5 exponent 2 plus logarithm of 320 out of 125. Now if that continues, we maintain half logarithm of 25 out of 4 base 10 minus logarithm of, now it implies 4 squared, so 4 squared gives us 16 and 5 squared gives us 25 plus our logarithm of 320 divided by 125. Now having known this, then you can also see that this half can also be written as an exponent to 25 out of 4. So without wasting time, then we should have 25 out of 4 all exponents half base 10. Actually, we should have also dealt with it alongside that of the squared. So we have minus logarithm of 16 out of 25, and we have logarithm of 320 divided by 125. Now at this point, we know that 25 exponent half is the same thing as square root of 25. That gives us 5. So we have logarithm of 5, that is square root of 25, and 4 exponent half is the same thing as square root of 4. That gives us 2. Now we have our base here, and minus logarithm of 16 out of 25 plus the logarithm of 320 out of 125. Not forgetting the bases. Yeah, very important. So the base is here is 10, base 10. We also have base 10 here. We have base 10 here. We have base 10 here. Now, having known this, then we can also write this as single logarithm by considering the laws of logarithm. So at this point, we can see that considering the first two terms, we can write a single logarithm as logarithm of 5 out of 2. Now once they are subtracting, then we can divide. So divided by 16 out of 25 to the base 10, and then plus logarithm of 320 out of 125 with the base 10. Now at this point, we can reciprocate that of 25 and then 16 by making the division sign a multiplication. Now we have here as the logarithm of 5 out of 2 multiplied by 25 out of 16 base 10 plus the logarithm of 320 out of 125 base 10. Now without much, then we can see that there is logarithm of 5 out of 2 times 25 out of 16 base 10 as one logarithm, and there is another 320 out of 125 base 10 as another logarithm, which means we can also write these two as a single logarithm once the bases are the same and then the logarithms are adding. Now you have logarithm of, that is 5 out of 2 times 25 out of 16. Now once they are adding, then we can multiply the argument, that is 320 out of 125 base 10. And with the help of our calculator, 5 out of 2 times 25 out of 16 times 320 out of 125 gives us 10. So we have logarithm of 10 to the base 10. Now, like we said earlier, logarithm of a number to the same base is 1. So at this point, log 10 base 10 gives us 1. So we also had the same answer compared to the previous example. Now let's try the next set of examples. Now in example 7, we can see that there is half log 81 base 3. So just like we did for the previous ones, we are going to do the same thing here. Now we have our question as half log 81. I think you have to write the 8 well, yeah. So we have here as 81 base 3. Now we can see that we can apply the power index law, or the product index law. Yes, it's the product index law. Now knowing well that we can send this half to the 81 becoming an exponent, so it becomes log 81 exponent half base 3. Yes, that works. In the same way, we can also maintain the half here and also express 81 as powers of 3. Now it implies that we maintain the half here and we have our logarithm of, now 81 can be expressed as 3 exponent 4 now to the base 3. Now we have half, and then we can see that this 4 can be written as a coefficient to the logarithm, that is 4 log 3 base 3. Now continuing gives us our half, and we can see logarithm of a number to the same base gives us 1. So log 3 base 3 gives us 1. And we know that half 4 times 1 gives us 4. And at this point, we can see that half of 4 gives us 2. And this is the simplest solution. In any ways, if you intend to bring the half to the 81, yes, you break it down, you're also going to get the same thing. So any of them works, yes. Now let's continue to the next example. That example 8 is a simplified logarithm of 27 base 3 plus logarithm of 16 base 4 minus logarithm of 64 base 8. Now with this, we are going to express the 27, 16, and 64 as powers of numbers. So that is a base and exponent. Based on the fact that we can see here that the bases are not the same. So based on that, we cannot apply the laws of logarithm directly. So cases where you don't have the base to be the same, then it is possible that you can express the argument as powers of numbers. Now having known that, then we have our solution as, so we have just logarithm of 27 to the base 3 plus logarithm of 16 base 4 minus, so it's minus the logarithm of 64 base 8. Now we know 27 can be expressed as 3 exponent 3, so you have logarithm of 3 exponent 3 for 27, plus we also know that 16 can be expressed as 4 exponent 2, that is 4 times 4 base 4, minus, in the same way we can see 64 can be expressed as 8 exponent 2, that is 8 times 8 gives us 64. Now having known this, we can now rewrite logarithm of 3 exponent 3 base 3 as knowing whether this exponent 3 is going to serve as coefficient here. So you have 3 logarithm of 3 base 3 plus, look at 4 exponent 2, we are going to have it as 2 logarithm of 4 base 4 minus, so in the same way you're going to have 2 logarithm of 8 base 8. Now we said earlier, and we've said it again, that logarithm of a number to the same base is 1. So you can see log 3 base 3, that is 1. So you have 3 multiplied by 1 plus 2. So log 4 base 4 also gives us 1, minus 2 log 8 base 8 also gives us 1. So at the end we have 3 plus 2 minus 2, and 3 plus 2 minus 2 gives us 3. So this becomes our solution to this question. Now let's try our last example for this video. So this is also similar to the previous example. You can pause the video and try. Now we have our question as 1 out of 3 logarithm of 8 plus 1 out of 3 logarithm of 64 minus 2 logarithm of 6. Now from the laws of logarithm, we made mention that if you have a logarithm and the base is not indicated, just like we see in this example, then it is in its common logarithm, that is, it has a common base of 10. If the base of the logarithm is not indicated, then it means that it is in the base of 10. So this example, we can see that it is in the base of 10. Now having that in mind, then we know directly we can express 8 as powers of 2, 64 can be expressed as powers of 4, and then for 6 we cannot express 6 as powers of numbers because there's no number when raised to an exponent gives us 6, so we maintain that, which means you have 1 out of 3 logarithm of, now 8 can be expressed as 2 exponent 3 plus 1 out of 3. In the same way 64 can be expressed as 4 exponent 3 minus, now 2 log 6 can be expressed as logarithm of 6 exponent 2. So it means that this coefficient is serving as an exponent here. Now we can also break it down by having 1 out of 3 here, and the 3 here, the exponent 3 can be written as 3 logarithm of 2. We also have here as 1 out of 3. The same thing implies to 3 logarithm of 4, and we have here as maintain the same thing, so we have logarithm of, now 6 squared gives us 36. Now at this point we can see that this 3 cancels that 3, so we are left with logarithm of 2, and we can see this 3 also cancels that 3 plus logarithm of 4 minus, so logarithm of 36. Now we can also write this as single logarithm, as considering the first 2 terms we can multiply them, so you have logarithm of 2 times 4, and then we have minus logarithm of 36. Now if that continues, then we can see that 2 times 4 gives us 8, and then logarithm of 36, we bring that one too. Also writing this as single logarithm, then we can write logarithm of 8 out of 36. and 8 divided by 36 gives us 2 out of 9. So our answer now becomes logarithm of 2 out of 9. So this is how we can simplify this question. And so this ends today's video. And thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. BakoMaths, thinking beyond infinity.